I have received several requests on how to set up a transparent filtering bridge in OPNsense. I know there's several guides that exist out there in video form and written form, but from OPNsense official and other sources. And this seems like it's gotten a little more popular lately because there's a lot of people that want to run their existing router or other network infrastructure, and they just want to use OPNsense as a firewall for some extra security and protection on their network. So a transparent filtering bridge allows you to use your existing networking equipment, but insert a firewall in very specific places in your network where you need that extra protection, where it's critical. So there are several places where you could put a transparent filtering bridge. If you have a separate modem or ONT and a router, and it's not an all-in-one box, you could put the transparent filtering bridge in between there on the perimeter, and it'll make the source or destination appear to come from the WAN interface, so you won't see which device it's coming from on your network. So you have a little bit less visibility if you put it there, but it's on the very edge of your network. So a lot of users will end up having a ISP provided modem, or they'll have a gateway appliance that they really like, or they want the extra visibility, and you could put the transparent filtering bridge between your router gateway device and your network switch where everything else of your network is connected. And if you put the transparent filtering bridge there, you'll be able to see the source and destination of all the devices within your network, because the traffic will be passing through that transparent filtering bridge where your firewall is. You could even put a transparent filtering bridge in front of a single VLAN if you want, such as I say a DMZ network, and you want an extra second firewall that's potentially a different brand than your main network firewall, and so that way they have to go through two different layers to get to your DMZ network. That's the nice thing about a transparent filtering bridge, is you can insert it anywhere where you really need the most protection or the additional protection. With that said, I'm going to do things a little bit different than the other guys, just because I think this is interesting. This is how I would do it if I was going to use one. And I'm a big fan of having a dedicated physical interface on devices that I'm managing for my network infrastructure. Most of the guys I've seen describe how to do this process with two physical interfaces, and then they add a virtual management interface on top of the bridge interface. So if you misconfigure something, you could lock yourself out of the management interface because you're trying to set up the bridge and also set up a management interface at the same time or around the same time. And I know that's what a lot of people struggle with, is like they do something and they don't quite get something right, and then they're locked out of their management interface and have to start over, right? or some people say they got the bridge working, but now they don't have access to the management interface, so they can't go back and make any changes, even though it works as it is. So what I am going to propose doing is using 3 physical interfaces. So you need a mini PC with 3 or more interfaces. So a lot of mini PCs will come with 2, 4, or 6 interfaces. Sometimes you'll see some with like 3 or 5, some odd number ones. And I actually have a device that has only 3 interfaces, which is perfect for this use case. That is the Go R86 that I had from a while ago. I'm going to use that device. It has just the right amount of interfaces, and there are 2.5 gig interfaces. So in this example, I'm going to put the filtering bridge behind, say, an existing router. Like if you have an ISP router or whatever, Unify, whatever router you have, I'm going to assume you're going to put the router first, and then the transparent filtering bridge, and then a network switch is going to be connected to that. And then that will insert the transparent filtering bridge before any of your other network traffic as it's passing through to the router. You'll be able to inspect it and put firewall rules and have protections there for all your LAN devices. So for that third physical interface that we're going to use as the management interface for OPNsense, I'm going to get that configured first before we even mess with the bridge. And then I'm going to plug that into the switch that's going to be on your existing network. And then we're going to access OPNsense from that management interface. So once we know we have that interface working, then we can mess with the bridge without worrying about losing access to OPNsense. Because as long as you can access the management interface from your main network, you're golden at that point, and you're free to mess with the other 2 interfaces as you please. And even if you mess that configuration up on those other 2 interfaces, your third interface that has your management interface will still be functioning properly, and you can still get in. What I'm going to assume is most people's home networks are going to be 192.168.1.1. It's that .1 network that most routers default to. OPNsense also defaults to that. I want to change the LAN network address. It's really simple because I don't want that to conflict with our third interface, which I'm just going to put it on the LAN network of an existing network assuming that's what most people are going to have. But if you put it on a different LAN or VLAN, or you have different IPs, you could skip that step. So then we'll get the bridges configured, and then we'll just put an allow all rule in, and then it should allow everything through, and we want to make sure the connection still works. Once we know that connection is working, I'll tweak a firewall rule and block all HTTPS traffic, just so that to show you from a client that's behind the bridge that the firewall rules are working. Then I want to show how you configure OPNsense so you can update the software, because now you got rid of the LAN and WAN in your bridge, but then you have one interface that's connected to an existing network, but now you have no way of accessing the internet from OPNsense to download updates. But there's a way that you can configure OPNsense that you can use the interface that's connected to your existing network and use that as your gateway. And once you have that stuff set in OPNsense, you'll be able to download updates like normal through that interface that's connected to your existing network, which is pretty cool. And then once we have the updates downloaded, then I'm going to install Zenarmor and put that on there and show how you can add Zenarmor to your transparent filtering bridge and have it filter ads and other things. But you can add various block lists and stuff to OPNsense. So I hope you will find this useful, because I'm going to try to show some examples as I'm setting this up, just to verify that things are working and blocking. Because sometimes when I've seen in guides where they'll check a box and say it's enabled, but they don't show if it's actually doing anything or working. And in one case I saw Suricata, they just enabled it, but they didn't download any rule sets or set a default policy. If you don't do that, Suricata is essentially doing nothing. And I don't want to lead you down the path of thinking that you are extra secure, but you're not really secure. So here is the example network that I'm using. I'm using the Grandstream GCC 6010 as my gateway router device, like you would if you had an ISP router or modem box. And I have a Grandstream switch and a PC connected to that switch and a wireless access point connected through that switch. And I'm going to be inserting the bridge between that Grandstream router and Grandstream switch so that I can filter traffic between those two devices and everything on my network. I'm going to be using the bogon R86S as the device to be used as the filtering bridge, because it has 3 ports, so it works perfect for this use case. And you'll need to connect a mouse and keyboard to that computer you're wanting to set up as the bridge. I'm using the Jet KVM device, so I can just control it from my computer real easily. And then finally, you need to put the USB drive in so that we can install OPNsense. Okay, so now we're going to install OPNsense. I plugged it in and it's booting up. And what we're going to do is just let it go through the automatic interface configuration, because it should put the LAN first and the WAN second. So that's how we have it plugged in that I demonstrated. Okay, so as you can see, I didn't touch anything for the automatic installer. I just let it roll through, and you let the countdown go down, and then it'll automatically set LAN and WANs. I'm doing a screen capture program, so I have a mouse cursor on here. Normally you wouldn't have that, but you'll see that it's 192.168.1.1, which is what most networks are going to default to. And I want to show how we're going to change and set up the other interfaces. And WAN's not connected to anything right now, which is fine, because we're going to set everything up in OPNsense first. So let's go ahead and type in here installer, and then OPNsense is the password, and then it's going to go through the installer. I like to use ZFS. It used to be UFS was the default option, but now they've switched it to ZFS at the top. I've noticed that in recent versions of OPNsense. And so it's a pretty good file system, even if you only have a single drive. I like using ZFS. And I already have a installation on here that I was playing around with. So that's why it said, do you want to override that Z root? And then we'll just pick Stripe and hit space bar to select the drive you want. All right, so now we can enter a root password. It's always good to set a good default root password. All right, now I go to complete install, and it's going to reboot. Now you can remove your thumb drive when it's rebooting. So now that we're booted up, we don't need to be plugged into this machine anymore with a monitor and keyboard, since we're doing this disconnected from the network just to get it set up, and then we'll plug it in and insert it where we want on the network. So now we can plug our PC directly into this, or whatever device you want to use, laptop, and we're going to configure OPNsense through the web interface. So now I'm logged into the computer I'm going to be using to control OPNsense. I'm using the Zima board in my example because it's a nice small computer that I can set up on my desk. and plug it into this example network that I'm doing. So we're going to do IP space A as a command in Linux, and we're going to see that I have an address in the LAN network on the OPNsense box. And so we can log into OPNsense now. We're going to use 192.168.1.1, of course, and we hit advanced and accept the risk. And then we're going to use the password that you created. I want to zoom in a little bit so we can see this better. And after this wizard pops up, and we can just click in the upper left hand corner just to skip the wizard. And you'll see here's a default installation of OPNsense. So what I'm going to do is I'm going to assume that your main network has a 192.168.1.1. And I'm going to make one small change to the LAN network interface to change IP ranges, because I'm going to make my third interface the new management interface. I want it to use that same network range. If you don't want it to be in the same network range, you could skip this part like I mentioned earlier. But the reason I'm doing that instead of making the LAN interface the management interface and the other two interfaces the part of the bridge is so that we don't mess up this interface that we're currently logged into, and so we can test the other interface while this LAN interface is still functioning. It's easier to prevent locking yourself out if you create a new interface. Make sure it works before you get rid of the old interface. And so then that's what I'm planning on doing. That way you'll have two interfaces you can temporarily you could get into OPNsense, and then once you know that the new manager interface is working, we'll get rid of the LAN interface, okay? And then we'll make that as part of the bridge. So it's just kind of a safe way of like, you just kind of swap interfaces, make sure they work before you cut off the old one. Because if you just cut off the old one and you mess something up, you're locked out, okay? All right, so now we're going to go to the interfaces, and then we're going to go to the LAN interface. And we're going to go down here and change the default interface IP from .1 to .2. We're going to hit save, okay? And then make sure that you do not hit apply changes yet, because we need to change our DHCP range so that we won't get locked out. Otherwise, you'll have to change your IP address manually. It's not that big a deal, but I just want to let you know that DHCP will not work unless you go over to here and go to LAN. We have to change the interface IP first before we change the DHCP range, because it won't let you. It says it's not in a valid available range, which shows up here now. So now we can actually change this range to .2 on both of these and save it. Once we save that, now we can go back to the interfaces, to the LAN, to just click on LAN and then click apply changes. So this is how you would change the IP address of the LAN network. It's pretty simple. You just change two places. You just have to make sure you don't apply changes until you're done. Okay. Notice now it's just spinning up here because I still have an IP address in the old network. So one way you could just do it real quick, you could disconnect, reconnect, or you could do renew release commands if you want to do it that way. But disconnecting and reconnecting works pretty well. If I do IPA, then you'll see that I'm now in the .2 network. So now I should be able to log in up here. Is .2, and if I go back in, you'll see that I can get back in. Okay, never save. All right. So now I'm back in, and so we just successfully changed our LAN interface. Now that we changed the LAN interface, we'll be able to create a new management interface that uses the .1 IP address. And so what we need to do is we need to go over to assignments and go to our third interface, which is not currently assigned because I just went to the default installation, and the default installation only sets up the first two interfaces. So we're going to use IGC2 on my hardware to create the management interface. I'm going to call it MGMT for management, and I'm going to click add. Now, after you click add, we just go over to the management interface. We'll click enable. And good idea to prevent interface removal, but that's to keep you from accidentally deleting the interface. And if we go to IPv4 configuration, we'll do static IPv4, and then we'll scroll down to the IPv4 section and do 192.168.1. And for the IP address, you should pick a static IP that doesn't interfere with your DHCP ranges on your primary network. I don't know what ranges you're using, so you will have to pick the appropriate value. I'm going to pick 99 because I know I start the ranges at 100 for DHCP. So I'm just going to pick a random static IP address in here for this network. And we need to pick /24 because that's just your normal subnet mask you would pick for any client device that you want to be on that network. It just tells you what the subnet range is. So /24, and we're going to click save. And you could click apply here because it doesn't hurt anything because it's on the third interface we're not even connected to. So let's go ahead and apply that change. So because we're using that third interface as our management interface, we do not need to set up DHCP on that interface like we would if OPNsense was our primary router. Because keep in mind, I'm going to be connecting this to an existing network, which should already have DHCP running and set up. So we don't need to enable DHCP. So let's jump over to the firewall rules section and we'll go to rules and we'll go to management. And one thing we need to do, because OPNsense by default blocks all connections on every interface, we need to allow access to the HTTP port on this interface so that when we connect to it from the network, it's not blocking access to it, right? Because it's by default, OPNsense is going to block everything. It tries to connect to that interface. So we need to add a rule by clicking add over here. And we're going to say it's passed by default management. And we want the protocol down here to be TCP. For the source, you could specify the LAN network range, but since we're not going to be using the LAN on OPNsense because it's going to be part of the bridge, you're going to have to specify the network range either in an alias or you're just going to have to type it in as a custom address. Where is that? Up at the top. Okay, so let's go here and we'll just go 192.168. Let's delete that any out of there. 1.0/24, and this will allow anything on the management network, which is the LAN network, to access this interface. You can be more specific if you want, but that way if you have other VLANs, it's not going to allow everything if we pick any. Okay, so it's a good idea just to specify that a little more specific. And then destination is going to be our management address, which is this interface address that we're currently on. And then we're going to pick HTTPS. We can type that in. And we can say allow access to OPNsense web UI. All right, so then click save. Click apply changes. And note that should be pretty much the only rule you're going to need for the management interface, because we're only going to be using this to access this management interface. So that's all we needed to do to create a new management interface. So now we can connect the management interface to the existing network as well as our PC. We can plug it back into the existing network and we can verify that we can access OPNsense's web interface from the LAN network of the existing network. And then that will ensure that we have everything configured properly so we can access the web interface no matter how we configure the bridge. So let's go ahead and test that out, make sure it's working before we get rid of the existing LAN interface to make it part of the bridge. So now let's plug both devices into the existing LAN network, and then let's do IPA over here. And you can see I'm now on the .1 network of the existing network. So now let's see if we can access OPNsense on 1.99, which is the static IP we set up for OPNsense. So let's type that in, 1.99. All right, and now we can get access to the OPNsense web interface, which is pretty cool. So now this verifies that our new management interface is working, and we can have access to OPNsense. All right. So this is great because this means that we can play around with the other two interfaces on the bridge and not interfere with this management interface. As long as we don't touch it, we have access to OPNsense from our existing network. And now we're going to continue with doing the bridge part of the guide, which basically you can follow the OPNsense instructions, even though they're pretty old, but they work to get the bridge established because that process is pretty much the same. Okay, so the first step is disabling outbound NAT, and that's under firewall NAT outbound. And we can go to disable right here and hit save and hit apply changes. You're not going to need NAT translation when you do a bridge because you're just passing traffic through the two interfaces that are in the bridge. And now we need to go to System Tunables, Settings, Tunables, and we got to change a couple tunable options. You may be tempted to click the plus to add the tunables, but that's not really necessary because those tunables that we need for bridges are already in this list of tunables. All we need to do is search for, let me copy paste this. Okay, so we're going to search for net.link.bridge.pfil_bridge, and you'll see it dropped us down to this entry here, and you see the default is set to 0. We need to hit edit, and we're going to enter 1 to enable this filtering on the bridge interface. So hit save. And then we'll just apply changes at the end because there's one more value that we need to change. And basically we can go down here and just change bridge to member. And it's actually a couple entries below the other one we just changed. And you can see it defaults to 1, but we need to set it to 0. So let's go here and click edit. And we're going to make this a 0. Now we can click apply changes. And the nice thing is these are runtime options. So that means you can change them on the fly and it should take effect immediately. Unlike other ones that say boot time, which means you'd have to reboot the system. So you shouldn't have to reboot the system to make these options work, which is great. All right, so now we need to create the bridge interface. So we just need to go over to interfaces, other types, and we create bridge. This is how you create a bridge interface. And for the member interfaces, we want to select LAN and WAN. And you can give it a description. We're going to be creative and call it bridge. And we're going to hit save. So now we need to go over to assignments, and we can assign that bridge as an interface. So you see it shows up here as a bridge 0, and we can give it a name. We can still call it bridge here as well if you like. Hit add. All right, so now we can click on bridge either here or over on the left side, doesn't matter. So if we click on the interface, we can enable this interface. At this point in the OPNsense instructions, you would create an static IP address on the bridge, and that's how you would access the OPNsense web interface. But since we have a separate dedicated management interface, we don't need to do that. So all you need to do is just enable this interface and click save. And again, click apply changes. So now we need to go to the WAN interface, and we need to remove these block private IPs and bogon networks because now you're going to be filtering traffic on your local network and you don't want it to be blocked by these default options on the WAN interface. And then click save and then hit apply changes. So now we need to disable the DHCP service on the LAN interface because we're not going to be using it as a standard LAN. We're just using it as part of the bridge. So now we need to go to services, ISC DHCP v4, and go to LAN, and then we're going to hit uncheck the enable DHCP server. So we're going to scroll down, hit save. At this point, I want to skip a couple of steps in the OPNsense documentation because we created a dedicated management interface. It's on a physical separate interface. And because the documentation states that you need to create an allow all rule on the LAN, WAN, and bridge interface in order to prevent you from locking yourself out while you're doing this configuration. And that's a consequence of creating a management interface on the bridge that you're creating at the same time. We had a couple extra steps at the beginning. So instead of doing it here to make sure you don't get locked out, we just did it at the beginning by creating a separate dedicated management interface. And we don't need to worry about the anti-lockout rule disabling it when we do it with the way we did it, because that gets applied to the LAN interface and all those rules get ignored when we create the bridge interface. So I don't think we really need to disable that anti-lockout rule. So you'll see that in your auto-generated rules on that interface, but I don't think it's of any concern because there's no IP address to access on that bridge. So now let's go back to the interfaces section on the LAN. Okay, so once you're on the LAN interface, you need to set the IPv4 configuration to none for both IPv4 and IPv6, because we're not going to need to assign IP addresses anymore to the LAN or WAN interfaces because they're part of that bridge, which is basically passing traffic through, so they don't need IP addresses. And if you go to the description, if you want, you can rename the LAN and WAN interface while we're in here, because they're not going to function as LAN and WAN anymore. It might be helpful for you to know which one you're going to plug into, but it doesn't really matter. We can call this in and out for the other interface, so that way you know that you're plugging something in, something's coming out. We'll hit save. We'll hit apply. And then on the WAN interface, we're going to do the same thing: IPv4 to none, IPv6 to none, and we can just call this as out if we want. And hit save. Hit apply changes. All right, so at this point, we need to create a firewall rule on the bridge. Otherwise, all the traffic will be dropped, just like any other interface that you create. So let's go over to the firewall section, and we'll click on rules and go to bridge. And you see there's no rules here, so everything's going to be blocked. So we want to just create an allow all rule to see if our bridge is working. Okay, this is a good way to test it out to make sure everything is functioning properly. So we're going to leave things at the default. If you're using both IPv4 and v6, you'll want to change the version for both IPv4 plus IPv6, and protocols any, source any, destination any of all protocols. So then we'll just say on the description, allow all. Okay, and then we'll just go down to save. We'll hit apply. So the bridge is ready to go to test out. And so what you can do now is plug your existing router into one of the ports of the bridge and then connect your switch to the other port of the bridge. So now you're inserting the transparent bridge in between your router and your network switch. I'm going to make the assumption that everything on your network is connected to the network switch so that you can filter traffic between everything, because if you have other things connected to your router, it's not going to be filtered by the bridge because it'll be connected directly to the router. Okay, so because this is only going to filter traffic, it's between your router and your network switch. All right, so now I've connected everything. So let's go over to reporting and we'll go to traffic. And let's select the bridge interface and we'll uncheck these other interfaces. And you should see traffic flowing in and out of these interfaces. So you'll see there's some in and out traffic going. And just for a quick test, I can see if I can access the internet from my PC. So as you can see, I can get to the internet still because it's going through that bridge and through the router and accessing whatever I need on the internet as though that bridge wasn't even there. So that, because we're passing all the traffic through. So one thing I want to do now that we know the bridge is working is test out a firewall rule to show how you can start restricting access to various things. So if we go to firewall and go back to rules and then we go back to the bridge, let's create clone a rule. So what we're going to do is just block HTTP access. So then if I go to try to access any website with HTTPS, it'll be blocked, and that'd be an easy way to tell that our firewall rules are working on the bridge. So I'm cloning this rule and I'm going to say protocol TCP, and then source can be anything on the network just to test this out, and destination is going to be any, but we need to change the destination port to HTTPS. Okay, we're going to say block HTTPS. So one thing we need to do at the top here, don't forget, we got to change pass to block. I almost forgot to do that. So we want to make this a block rule, hit save, and it's going to put it at the bottom when we clone it. So let's move it to the top. So because it's allow all rules, it's going to interfere with what we're trying to test here. So let's move it up to the top because we want to block it first before we allow everything, right? So hit apply changes. So let's do Microsoft.com, and you can see it's being blocked. We can do my website. If I can type, it's not accessing anything. So we can see that we're getting blocks for HTTPS, and so you can see how you can start restricting things with firewall rules, and that's a good way of testing that out. So let's delete this rule, apply changes. And if we go back there, you can see we have access now, okay? Before moving on, I want to show one thing real quick. If we go to System and go to Firmware, and we try to update OPNsense, you'll see that, if I go check for updates, it says no address record found for selected mirror. And you see it basically fails to connect to OPNsense because we no longer have a WAN interface to connect out to. So we need to be able to specify how to get out to the internet. And so basically what we need to do is use the management interface that's already connected to the primary network as our gateway to the internet, because it already has connection to the network, and we're going to make that our new gateway so that we can get access. This is basically the same as setting a static IP on your system. So if I go to here, let's say on this Linux system, and I click on IPv4, you'll see if I click on manual, there's a place to put DNS servers and a gateway. So if I hit add here, I have to put an IP address, a subnet mask, and a gateway IP address. But since we basically have done so far in OPNsense created the address and net mask for the management interface, but we haven't specified a gateway or DNS server yet. So I'll show you how to do that. And so now let's go to gateways, configuration, and we'll click add. And then we'll just call this gateway MGMT because it's on the management interface. And the interface we got to pick is the MGMT management interface. And we're going to specify the gateway IP address, which is not going to be your management interface address. It's going to be 192.168.1.1, which is the gateway for that network. Okay, and that will be your main network's IP address, whatever it may be. Okay, so that's all we need to add here, and we'll just hit save. We'll click apply. If you're doing IPv6, you would need to create another one for IPv6. I don't think you can do both in the same gateway. OPNsense does that as well. When you're using DHCP, it automatically creates an IPv4 and an IPv6 gateway. So keep that in mind. If you're using IPv6, you'll need to create another network there, okay? And now one more thing we need to do is go to Settings, General, and you'll see DHCP servers down here at the bottom. These are the DHCP servers that OPNsense itself is using. So it's not the ones that your network that OPNsense is controlling is using, because that's what's always confusing. If you're new to OPNsense, you might want to put your DNS servers in here, but that's only OPNsense itself because it needs access to the internet to do updates. So that's something, a little tidbit there in case you weren't aware of that. You just do 192.168.1.1 is what we're going to use for our DNS server. And we'll just hit save. Okay, now we need to go to firmware and we'll go to status. And we're going to see if we can check for updates now, see if it works. Oh, looks like it's downloading now. So it looks like our interface is working. That means DNS is working and our gateway is working. So it knows where to go now to get access to the internet, which is really cool. So yeah, now we have the latest OPNsense update. So let's go ahead and update this to get the latest changes before we continue in this guide. I'll just skip through this really fast and we'll continue from there. All right, so now we're back to OPNsense and we got the latest version installed. Now that we have access to the internet and we got OPNsense up to date, I needed access to the internet anyway to be able to set up plugins like Zenarmor. So I want to go ahead and show you how that works. So let's go to System, Firmware, and then we go to Plugins. And we should be able to type Zenarmor. It's loading. And then we just hit add to this repository. Okay, and we go back to plugins. And there should be more plugins here that show up. There we go. Now they show up. And now we just need to install the Zenarmor plugin. I know a lot of people like to use Zenarmor. I still use it on my network. Now that Zenarmor is installed, we just need to refresh our page so that it'll show up on this menu. So let's go down here. Let's click on the dashboard and it's going to walk you through the wizard. So let's click on the terms and service and hit agree. And now it's checking our hardware to see if it's capable of running Zenarmor. You will want to have probably at least 8 GB of RAM to run Zenarmor if you're going to run Elasticsearch on your box. And you'll see that it says we're good to go and we can just install Elasticsearch. You can do Elasticsearch version 5 or 8. I just do the newest version since we're starting from scratch. And it just says it's different than the previous installed. I don't know why this message pops up, but we don't have anything installed yet. So, so we're going to install this and go ahead and get through this process. All right, so now we got the database installed. Let's click next. And the deployment mode here is kind of interesting because if you see here, it defaults to L3 mode with emulated netmap driver. If you drop down this box, you'll see they actually have a bridge mode with L2 blocking with a netmap driver. So you might be tempted to use bridge mode with Zenarmor because you're creating a transparent filtering bridge. But if you do that, you're going to bypass the bridge that we just created in OPNsense, so the firewall rules won't work on the bridge that we created. You can basically probably create your own transparent filtering bridge with just Zenarmor if you like. But if we want to have both to give you more flexibility to add firewall rules in OPNsense, but also use Zenarmor, you can still leave it on layer 3 because it just looks at the IP address layer 3 traffic instead of looking at a lower level, and it still does the blocking and filtering that you need for your network at the layer 3 mode. Okay, so now we picked layer 3, and the interesting thing about Zenarmor is it doesn't even pick up on the fact that we have a bridge configured, but you can still select these individual interfaces because it's going to look at the traffic flowing through those interfaces. And so we need to go over here and set up a security zone for these. We could just say LAN because both of these are going to be on the LAN network. It doesn't really matter what you pick for these security zones. It's mostly for you for identification. You can use them in policies and that sort of thing. So that's the only main reason you'd want to tag these differently if you want to use different policies for different interfaces. So let's click on next. And we can just do the free edition to try this out. And you can pick up to 100 devices and hit next and hit complete. All right, so now it's restarting the packet engine. And you should be able to see traffic flowing through these two interfaces, which make up our bridge, okay? And we have all these different stats and cool little charts and stuff here, and nothing's going to show up until we get some more traffic flowing through. So one thing I want to test to show that Zenarmor is working, I'm just going to go to a website that has some ads, and then we're going to see if I put a policy in place to block ads, if it removes the ads from the website. So then you'll know that traffic is being blocked properly. So let's go to a website, maybe like msnbc.com. Some of these news websites have like tons of ads on their websites. You'll see we have some ads popping up here. Okay, so now let's go here to Zenarmor and we're going to create a policy. And we have a default policy. When you have a free version, I think you only get a default policy. So let's go to security and we'll go to, we can do all these essential ones: malware, phishing, hacking, spam. And then we'll go to, you can't do any of these advanced ones unless you have a subscription. So we'll go to app controls and we can see how we have ad tracking and ads. This is for apps, but for ads on web, you need to do category based controls. And we're going to do moderate control, and notice it will block advertisements here on the web. So for web pages, you need to do web controls. For ads that are in your apps, like your mobile devices and stuff, you want to have it blocked on app controls. Okay, right here. Now let's go ahead and apply changes. Okay, now let's go back to here, and I'm just gonna refresh this page, and we'll see what happens. We have to give it a second because this is slow to load with all this stuff here. The main thing it should be blocking is this ad right here. And it looks like I don't see any ads right here. So it looks like it's working pretty good. So we'll just sit here and wait a second. And then let's go back to policies, and I can show on the live sessions that it blocked some ads here. If you look at here, we see we blocked some ad trackers and we blocked some ads right here. And it looks like an Amazon ad, as maybe what was shown at the top. So this is a good way to see that things are actually being blocked by Zenarmor on your network, and you get some extra filtering and protection that Zenarmor provides. One thing I want to mention here before we continue is, since we put our transparent filtering bridge between our router and our network switch, you should be able to see devices from all your VLANs come through that, because everything has to go through that bridge. So to demonstrate this, I connected my phone to a different VLAN on my wireless access point I have on this example network. And I'm going to refresh this page because I went and tried to access a news site. As you can see here, it's the .40 device that's on my guest network that I just set up real quick. And it's blocking ads like we said we want to do in our policies. So that's pretty cool. From this live log, you can see devices across your whole entire network. So some users prefer to use the built-in intrusion detection, which uses Suricata in OPNsense. And I'm going to show how to set that up real quick, but just keep in mind that Suricata is not necessarily designed to block things like ads and those sorts of things. It's better suited for if you're trying to protect apps and services that you're hosting. They have a bunch of different rules for different types of apps and services and devices that you have on your network that are known to be vulnerable. And also keep in mind that Suricata's rules, if you do the free rule sets, are like 30 days old. So if you want quicker refreshes, you need to pay for the pro rule sets. For a home network, you have to decide if it's worth paying for those extra rules, because Suricata's not going to be able to protect you from 0-day things that are happening within the last 30 days. Just keep all these things when you're setting up your security for your network, because you don't want to have a false sense of security, which is why I'm demonstrating how you can kind of test and poke around to see if things are working. and verifying that things are getting blocked. Now let's go to services and go to intrusion detection and go to administration. I want to show how to set up Suricata really quick because I watched one guide and it just showed enabling it and clicking IPS mode, and that was it. But there's a lot more to Suricata than that. This will not block anything at all, and I don't want you to enable those things thinking that it's going to protect your network, because the reason is you have to download the rule sets and you have to set a default policy before anything will work at all. Okay, so what we need to do is go to download. All right, so now that we're on the downloads page, you need to click this box and we're going to click enable. You have to enable the rules that you want before you click download, or it won't download anything, okay? So I'm just enabling them all for this example just to make it easy, and we'll just click download rules. But you want to make sure you find the rules that are most applicable. See, there's a lot of rules in here. You don't want to enable everything because you're going to do extra processing with these rules, and if you do too much, it's going to slow down your throughput a lot. All right, so now after waiting a few minutes, it shows the last updated, and for some reason these two here, I'm refreshing, it says not installed, so I'm not sure what's up with these, but at least we have some rules downloaded, so that's one thing you have to do first. And if you click on the rules page, you can see all the rules that are here, and there's like a lot of them, right? So there's like thousands of rules. It says 167,000 entries. So you probably don't want to browse this too much. You probably want to search for them if you're looking for something specific, if you're wanting to do things. And notice a lot of these are disabled by default because maybe they're just out of date or obsolete. You can enable these rules if you think you need them. Okay, now that we have the rules downloaded, we need to go create a policy so we can say how to handle these things, because it used to be you had to handle all the stuff individually, but they created this policy page so you can handle large amounts of rules more easily and more effectively, and it reduces the amount of processing required for handling all these rules because they can be treated as a group. So let's click on the add button here. All right, and then you can give it a priority. It defaults to 0. And then the rule sets, you can pick which rule sets you want to use. If you select nothing, it says all will be applied if you don't want to, if you're not doing a specific policy on a specific rule set. So it's better to leave it as nothing selected, because that way you don't have to click like 100 different rules if you want to use a bunch of them for whatever reason. Okay, and this one is the action. We're wanting to say this is what the current action is. So if you look at the description here, this is the rule configured action. That's what we saw in that rule list page. So we want to say everything that is set to alert or drop, we want to come down to the bottom here. These are extra filters that we don't really need. If we go to the bottom and we say the new action is drop. So we want to say, we're basically saying everything that is set to alert, we want to set it to drop. And you don't have to do it that way, but that gives you more rules to drop more traffic, because sometimes you just want to alert on something and not actually drop the traffic. So if you do want more blocking automatically without you having to go look through all the logs, this is one way you could go about it. You can just configure this how you see fit and click save. Okay. And then let's go to administration, and then we can go to enabled and then IPS mode. If you have to enable IPS mode if you want to enable blocking, and then you set the interfaces that you want to operate on. And since we now have a bridge, we can set it on the bridge interface. So we should be able to set it on there. And the pattern matcher, you may want to do hyperscan, because I tested some of these out before, and I think hyperscan performs the best. So then you just click apply, and then that'll enable Suricata. I'm not going to actually click it right now because I have Zenarmor enabled. Zenarmor and Suricata cannot be enabled on the same interface at the same time. So because they both are using NetMap and then they interfere with each other, that's why they often will say use Suricata on the WAN interface to protect, like if you're hosting any web services, and then use Zenarmor on the LAN interfaces to protect all your LAN interface traffic from various attacks and blocks and those sorts of things you want to do. Unfortunately, with a bridge, you only have one interface, so you can only use one or the other. You can't use both Suricata and Zenarmor. And so you can also install other plugins like CrowdSec, and which basically gives you some protections on your web interface of OPNsense and the SSH interface, and it also gives you a block list that you can enable on your network to block traffic going to and from malicious IPs. So that's a possibility. You could use that in conjunction with Zenarmor or Suricata without interfering, because it's just like a firewall block list. And you can also make use of unbound DNS block list. If you go to unbound DNS on the left here, and go to the block list page. So you can start adding more and more security features that you see fit for your network now that you have this bridge established. So I just wanted to show a couple of those things and not necessarily every single thing you could do, just to give you some ideas and what you can set up on OPNsense and how you can go about testing some of those things to verify that it's working. Because otherwise, if you just enable it and then and not check anything, you might not be doing any protection at all, because the way the bridge will work, traffic will still flow through, but you're not gaining the security protections that you are most likely looking for by creating a transparent filtering bridge. So I hope you found this guide to be useful, and I try to take a little different approach with how to deal with the management interfaces, because I think that is a good way of approach to take to make sure you don't lock yourself out of the bridge. It's not dependent upon that bridge, and you're free to configure the bridge however you want, and you have a separate interface. You can manage OPNsense and download updates and those sorts of things. It was a really fun video for me to explore new things I haven't tried before with OPNsense, and so I was going down this rabbit hole just figuring out these different things. It was fun for me to play around with. I just had to have time to do it. That's the hard part, right? So until next time, I'm Dustin Castro, and I'm signing out.